Okay, hello, my name is Dan. In this video, I'm going to use logical volume management and specifically the snapshot feature of LVM to implement something that's similar to what you can do in deep freeze with Windows, which is basically to um, have like a base installation of the operating system that the computer reverts to every time it's rebooted. So, the end product is going to be that we're going to have an environment such as this where we can install whatever we want. We can change and customize anything that we want. We can even rm-rf the root directory, and then with a simple reboot, it's just going to come right back up to this base installation, which again is just I just installed a new. Well, I just installed and partitioned a new. I partitioned and installed a new Ubuntu 16.4.1 desktop environment, and I'm just gonna pull up a console here, or terminal, and so I'm going to show you what we got going on here. With ls block, we can see that there are 4 partitions. SDA1 is boot. SDA2 is a partition with, and SDA3 is a second partition of equal or relatively equal size. SDA4 is the swap partition. Now, if we look at volume groups, let me make this bigger. We can see that there's one volume group, Ubuntu VG, and that volume group is actually, so it's 19.27 gigabytes. It's actually spanned over SDA2 and SDA3. And then if we look at LV display, we can see that there's one logical volume at this point, which is root in the group of Ubuntu VG. It is 9.17 gigabytes. And I've actually specified that that should live solely on SDA2. So what I'm gonna do is I'm going to write an init script and compile and add it to init ramfs that on reboot every time it's going to wipe any snapshot on SDA3 that's present, and then it's going to take a snapshot of Ubuntu VG root onto SDA3, and then Grub is going to pass to the kernel, root being SDA3, which will be our snapshot. So what that means is that we'll boot into the snapshot. It's going to be a read-write snapshot. It's going to look exactly like Ubuntu VG root. However, the snapshot is refreshed every time we reboot. And so we need to do 3 things in order to do that. The first is going to be to set up our init ramfs script. Well, first thing is to install LVM2. Oh, and we already have it. Okay. So the second thing then is going to be to create our init ramfs script. So if we go to cd etc init ramfs tools scripts, and we look in here. So these are these different directories signify different points during the boot process that we can introduce a script into it. I'm only familiar with a couple of them. I know that init bottom right here, that is right before init ramfs turns the system over to systemd. What we're interested in is the local pre-mount right here. And so what that's going to do is it's going to allow us to insert a script into init ramfs that will act before any of the what will eventually be the file systems that are used, before those are mounted, so they're free to be messed with, so to speak. So what we're going to do is go into local pre-mount, and then we're going to make one that's called snapshot. Snapshot. Okay. Oh, and we don't have Vim. That's one thing I haven't done. And I know I could use nano or even I think VI is probably installed here, but I'm used to Vim. That's what I learned on, so it takes but a second. Okay, so Vim Snapshot. Okay, so this took me a while to figure out where to put it and how to do it. This right here actually, oops, shebang bin, now not bash and not sh, it's actually busybox, and I didn't know that until I dropped down into initramfs and saw that I was dealing with a busybox shell. So, and then sh I've seen specified in init scripts online, so I just included that because it ended up working. So, well, where am I here? Froze for a second, I think. There it is. Okay. So what we want to do now is we want to write, basically it's just a 2-line script. And what it's going to do is it is going to, the first line is going to delete the snapshot that's there. Now we're going to name our snapshot, that's going to be the name of the device. And so this is another thing that tripped me up. In busybox you have to specify, I guess it's called the module, or I don't know a better word for it, but the module that you're going to be using. So we specify LVM by LVM, and then we write our command lv remove, and then -f to force, and then what will eventually be the device name. So dev Ubuntu VG snapshot. Okay, so that's our first line, and that's basically it. So that's going to delete the snapshot. Then our next line is going to create a snapshot. Now what I need to do here is actually see the, let's see, the terminal. I want to see, what is it, volume group display. I want to see sudo vg display. Okay, we have 2,586 physical extents remaining in the group. So that's what we're going to make. That's the size we're going to make it. So again, we're specifying, make this bigger again, specifying LVM, if I can type, LVM, and then we're going to, the command is lv create -l for physical extents, and it was 2586, and then -s for snapshot, -n to name it. We're going to name it snapshot. We're going to create it in the dev Ubuntu VG, or no, we're going to take a snapshot of Ubuntu VG root, and then this last thing will specify that the snapshot lives, or this volume that we're creating lives on the particular device SDA3. Now I don't know if this adds any sort of resiliency to what I'm trying to do to put it on a different partition, but I don't know, I just did it that way. So that right there is the init script. Pretty simple, just 2 commands. That took me probably 2 days to figure out. So, but I was able to, I did it without asking really anybody, which I know is kind of the stupid way to do it, but I just used my Google skills and man page skills because I wanted to try to really figure it out and really get to know it. So once you add a script, you need to update initramfs. So update, oh, let's clear this so you can see a little bit better. Clear, update, initramfs, and then we, nope, no snapshot. It's -u, that's to update what's already there. So now it's generating, you can see initrd.image 44031 generic. Now hopefully it's going to return with no error. Okay, so returned with no error. Now from my experience, when you generate that image, it's actually going to go ahead and it'll run through the script. So we should see, we did not see. Oh, I think because, let's see, ls-l, okay. So I think because the permissions aren't right. So let's chmod 777, well, chmod plus x, how about that? Snapshot ls-l, okay. So now let's try it again. Update init remfs. And it's thinking. And there you see, oh. Failed to find logical volume snapshot name starting snapshot are reserved. Please choose a different LV name. Okay, so I never actually ran into that error before because I what am I doing? Yeah, Vim snapshot, because I named it snap. So let's just go ahead and do that. Snap. Oh, SGA3 over here. Snap. Write that out. Now it may have created. Nope, it didn't. Just errored out. Okay, so now let's see if we can keep the name that the name of the script snapshot. So update dash init mfs dash u dash u. And let's try it one more time. And hopefully again it'll return without an error. Yep, there you go. So it failed to find logical volume, but you can see a volume popped up right there. It failed to find it because we hadn't created it yet. So if we go ls block now, we can see that now there is Ubuntu VG, well, there's a lot of stuff. Ubuntu VG snap dash COW on SDA3, and under that the snap, and that's exactly what we want. So okay, so that worked. So now let's clear screen, cd home. So now what we want to do is we want to, what do we want to do? Oh, we want to edit Grub. So we can't just edit the grub.config file in boot. What we need to do is we need to vim etc default grub. Okay, we're going to add a couple of things here. So the first thing we're going to do is under the grub command line, the Linux command line, we are going to go ahead and pass a new root ID. Well, it's actually not an ID, but a new root name to the Linux kernel. And that new root name is going to be the same thing that we created. So it's going to be /dev/ubuntu-vg /snap. Okay, so that's going to write over what's default in Grub, which is the root ID of our actual root, the one that was installed during installation of the system. Now what we're going to do next is we're going to type grub, we're going to add a line, grub disable OS prober. Now what was happening was this was working, but once the system was initialized, I was continuing to get a grub menu popping up on boot, regardless of what the timeout was or what the hidden timeout quiet, you know, all of the above configurations that normally prevent the menu from coming up. It was continuing to come up, and I didn't necessarily want that. I wanted the system or the the system that we're installing or putting into place, I wanted it to be fairly invisible. I wanted it to look like a normal boot, and yet Grub menu was coming up. One of the things that I found was to add this grub disable OS prober equals true, and I believe what that does is it prevents Grub from looking in the other partitions for any kind of operating system, because what was happening was I'd pass the root dev Ubuntu VG snap, and it would have two options on the Grub menu, one for the snap and one for the root partition. So that stopped happening once I added grub disable OS prober equals true. So I'm going to add that, and then the final thing we're going to add is this grub record fail timeout equals 0. Now, why are we adding that? So basically, the last thing that we're going to do is we're going to play around a little bit in FSTab or FSTab, and one of the things we're going to do in FSTab, and you don't necessarily need to do this, but we're going to specify that the boot partition gets mounted as read only. The reason that is because once the system's in place, I want to be able to do anything up to rm-rf, the root directory, and then reboot and have it be back to normal. What was happening was when the boot partition was mounted as read write, what was happening was it was deleting the boot partition, and then I couldn't boot back up. And so I specified read only, and that grub menu would continue to pop up, and none of the options here seem to change that. So I finally turned to Reddit, and user Koera, Koera, on the Linux questions subreddit, which is a great subreddit, he actually pointed me in the direction of this option. I guess he's a sysadmin out there, and apparently he or she is a sysadmin out there, and apparently when boot is read only, or actually when the attributes are immutable, or if it's not automatically mounted, those were all three options that caused the menu to come back up. It would pop a menu with a 30-second timeout, regardless of what I did in the rest of this file. Now, when I add grub record fail timeout equals 0, I guess that specifies the timeout when there's an error during boot with grub, the timeout remains 0. So at any rate, that was a lot of talking, but that took me a long time to figure out too, and I actually didn't. I had to turn to Reddit, which is a great resource. So after we edit grub, what we need to do is update grub. Update grub, and it's going to generate, and it's giving that warning, and that's okay, so that's good. Okay, so the last thing we need to do is make some changes to FSTab. So we're going to go vim etc FSTab. Now what we're going to do is we are going to add a new line. We're going to say dev mapper Ubuntu VG snap is going to go onto root. It's going to be an ext4 file system. It's going to go with same as below, errors remount -ro. Boom. It's going to go with a 0. Basically, we're just copying everything that is on the root. Okay. Now, with the root, we are going to specify that root gets mounted onto mount, which is the temporary mount point. Or, I should say, yeah, so it gets mounted onto mount, temporary mount point. We'll go ext4 still. We're going to get rid of this errors remount -ro, and we're going to say no auto, so that it doesn't automatically get mounted when FSTab is read, and we're going to go read only if it does get mounted. And then we're going to, did it freeze on me again? Oh, there it is. And then we're going to specify that no dump, and we're going to go 2 for FS check, and then down here on boot we're going to go defaults plus read only. Now, why do this? Obviously, deep freeze And what I'm trying to accomplish here is not a security thing. Anybody that can rm-rf is going to be able to bypass that and get to the underlying file, the actual file system. Anybody that wants to attack the system is going to do it as well. But I just want to make it fairly robust, I guess, the implementation, and so I want to be able to rm-rf the root, and also I want to make it a little bit hard to access the actual OS installation on Ubuntu VG root, and so I just did this because why not? So anyways, there's that. Okay, so that's good. I'm trying to think if there's anything else. I think it's just those 3 files that need to be done. So in that case, we'll take a look at ls block. We see that Ubuntu VG root is mounted onto root, boot is mounted onto boot, and swap is there. And that's the layout of the devices. So let's hit a reboot and let's see what happens. Reboot. It took me a long time to figure all this stuff out, but it was very interesting. I really enjoyed this project. And this is taking longer than it should. A lot longer than it should. Let's see here. Let's just try to force a restart. And let's see what happens. And you're going to see a whole bunch of output here from our init script. And then it's going to hopefully drop down into a desktop. Seems like in a lot of these videos the VM kind of craps out on me. Maybe it's because I don't have VMware tools installed. I don't know. Anyways, so let's take a look. ls block. Boom. Okay. So we see we have the snap. We see that SDA1 is mounted onto boot. We see that we have the root here that's not mounted onto anything. We see that the snap here and here is mounted on a root. Now, if we try to, let's see, sudo s password, oh, I think I hit a wrong key, password, even as root, if we try to touch mount, or, can't type, boot 1, read-only file system. So boot is mounted read-only, snap is mounted onto root, and again, if we ls and look at root, it's exactly the same. However, watch this. rm-rf root. Oh, and Ubuntu's little no preserved root. And say goodbye to everything except for what's on boot, which is a read-only file system. And all those things that are API file systems, and I can still type, but no ls, no cat, no nothing. So basically I have just rm-rf. I can't even reboot. But if we go vim, power, restart, let's see what happens. And we should see the same output. And if we were to stop and take a look at that output, what we're seeing is that the snap is deleted, the one we just rm-rf'd, and it's getting retaken from the root file system, and desktop comes back up, and ls block, and we can see that we're back on VG snap, which is mounted on the root. And yeah, so that's basically it. I mean, so there's a number of different ways to implement this. I chose logical volume and LVM because that's what we were studying in class, and the instructor just made a side comment or a comment that basically said you could implement deep freeze in a couple of lines of script and a little bit of configuration of the files. So I chose to go that way. I understand that, this is basically what a live boot CD is. And then also there's file systems specifically for this, like Overlay FS, that uses temporary file systems overlaid on top of the your traditional root file system to accomplish this. But this was just the idea that struck me, so I figured I'd give it a shot. Took me a couple days, a lot of man paging, a lot of Googling. Eventually I had to turn to some people for some help, but I got it done. Yeah, just a useful thing. Maybe you want to put it on a kiosk or on a user's computer, or not use it at all, but just, I think it's kind of neat. So anyways, thank you very much for watching, and yeah, see you next time.